Good day, grade 12 learners. Welcome to today's technical science lesson. My name is Jabu Sitole. This lesson is brought to you by Gauteng Department of Education in collaboration with Saibono Discovery Center and broadcast by Phakama Research and Development. Learners, today our lesson is about, or the topic is about work, energy and power. When I look at the work schedule, I see that we are starting with this topic this week, henceforth. And this topic, you are from the momentum which we were dealing with 2 weeks back. Now we'll be starting with this. So it means we are on par in terms of the work schedule. So it might be a new topic to you, but it will add an advantage for you because you will be moving with the teacher as we are moving along. At some point we'll move fast, at some point we'll move steady, and then for your clarity. Now, I always, when I start, I look at the exam guideline. What does the exam guideline say to us? Because it is a guide to us. Now, the topic that we are dealing with, work, energy and power, it's under or falls under mechanics. Then I said it there last time, the marks that are there in mechanics are 93 marks. And in this 93 marks, the work, energy and power contributes to these 93 marks. So in other words, the energy and power is embedded in this mechanics that we are dealing with today. And the weighting thereof is 62. Then the paper that you are going to be writing is out of 150. So that is where we start all the time. That is where I've encouraged you in the previous lessons that you need to look at this exam guideline because it's guiding us as to what do we expect from there. So what we are dealing with is mechanics, energy, work, energy and power is included in mechanics. And the mechanics, we can see that it has having a bulk of marks, a marks which is 93 marks. So then it means there's a lot of work that we need to do in mechanics. Now, this is the framework that we want us to look at. This is what is going to guide us as to what is it that we expect in this topic. Work, energy and power. We'll be starting with work. Then we'll go to energy, we'll go to power. It means we'll take lesson by lesson so that we cover all the subtopics that are there. Now, if we look at work, we'll be defining what is work. Remember, in science, we need to have definitions. We have to define so that you understand what is it that you are dealing with or talking about. Now, through your definition, you will be having the formula that we are going to use to calculate the work. Because that formula will base on the definition of work. Then we'll be having the SI unit. The SI unit, it's there to guide us or to tell us what is it that we have calculated. Remember, always I say, you may calculate, you may have your formula, you may have your substitution, you may have your answer as the magnitude, but if you don't put an SI unit, then they will deduct what mark? A mark for that. So please, learners, you must be careful about that. So we'll talk about the SI unit for work, which is the joule. Then we will talk about energy. We'll define what energy is, and then we have types of energies or forms of energy that we're going to talk about. So energy, we'll find that the SI unit for energy is joule, because it emanates from what? From work, because the SI unit for work is joule also. So we have forms of energy. Now we've got the gravitational potential energy. I'm speaking my language very well. It's gravitational potential energy. Is not potential energy. It's gravitational. This one is very needed because of this G that is there. So that gravitational potential energy, it's needed. That gravitational, it is needed, is the force that accelerates an object downwards. So that we need to call it correctly as gravitational potential energy. Now we've got the kinetic energy. Now that in itself, it tells you this one, it's an energy that the object possesses while it's at rest. This one, an energy that an object possesses while it's in motion. So because of this velocity that is there. So these are the two forms of energy that we have. And we have the comprehensive energy. We call it mechanical energy. Then the chemical will define it as well, because we'll define each and every type of energy that is there. This is the sum of kinetic energy and gravitational potential energy. So we'll define it and we'll make calculations around these energies. Under mechanical energy, we've got the law of conservation of mechanical energy. We'll talk about this as well. We'll make calculations as well. So this, I'm looking at this sketch that we are presenting and we are talking to. This sketch is going to, or the framework is going to guide us as we move along, so that it make things easier for us to understand what is it that we are going to come against. So having done the work and defined the work, we do the calculations on work, then we are sure that we understand what work is and how we calculate work. We'll move to energy. We'll talk about the types of energies and the forms of energies, the energies that we have, and the principle of conservation of mechanical energy. So we'll talk about this after we shall have dealt with work. Then we do the energy. Then after completing the energy, then the calculations and all about energy, we will then go to power. Then we will define what power is. Then we'll use the formula to calculate power, and then the SI unit for a power. Remember, here in power, we are specific. What is it that we are going to calculate in terms of power? So we will be guided by our what we call exam guideline as well, as to how far do we go in terms of power. So most formula that we're going to use in power, we'll be using the formula with having a velocity, all right? Because we have formula that calculating power with a velocity. So we'll look into all of this framework. At the end of the day, we shall have touched everything that is in our framework. So this is what I always encourage for you learners and you educators to have in front of you while starting the lesson or the topic. So learners must be given this to pace it and then move step by step with it. They will understand easily to say what is it that is expected to them to understand as to the calculations and the definitions, because we need our learners to grasp the definitions. Remember, I always say in definitions, it's true or nothing. So you must know the definitions. So the topics, they got definitions, so you must know the definitions. Right. Now, let us move on. So I understand and I believe that you are comfortable, you are satisfied with the framework that way. You now follow what is it that is gonna happen, what is gonna be unpacked to you, and then you'll move on. If you seem to forget, you'll go back to the framework. You just check. I want that at the end of the lesson, you check as to what is it that we have done, what is that we didn't do, so that we have a tick list that will make you to understand and say, oh, I didn't hear this. Let me just call and then find out as to what is it, why this has been not mentioned. So we go to work. In physics, this term work distinctively differ from its everyday meaning. Now, in everyday meaning, the term work, which we were talking, I'm doing work, it means you are busy doing something. We are busy washing, we are busy ironing, we are busy doing that. We term it in a layman language as we are doing work. That is work. That is our daily language of work. Is being busy, being doing something. That is work. But in physics, it's different. It's very different. In physics, we say work is done. Work is done only when the object is moved through some displacement. Work is done when an object is moved through some displacement while the force is applied. That is physics. In other words, if you apply a force on an object and the object move to a certain displacement, then you shall have done work. So that is in physics. So it's not that you must keep busy, you seem busy, then you do work. So there must be a movement of an object to be displaced in some way, and then the force is applied on it. So that is how we see that work is done. So when force is applied on an object, such object is displayed. It says move from one position to another. So you've moved the object from this position to another position. In other words, what did you do? We have transferred energy to that object because it has caused the displacement. There is a force that applied to that object, moving the object to another position, which is it causes a displacement. Then that shall have done work, and then we have done what? We have transmitted an energy or transferred of energy. So energy is transferred. So energy in an object can be gained or it can be lost, depending on the type of force that you are is acting on an object. So the energy can be gained if I push an object, so it gains an energy. If I take out, I lift an object and I move an object somewhere, I can lose an energy. So it can be gained or lost. We'll talk about it, we'll unpack it as we are going to explain. So what I want you to just to understand the concept of work in terms of a layman's language or a daily language and the scientific term of work. So in other words, while we are dealing with work, in other words, you need to have a force applied on an object and the object must be displayed to certain displacement, or it must move through a displacement. So that is how work in scientific term. But let us define what work, the definition of work. This is very important. Nota bene, note well. The definition. Remember, definition is 2 marks or 0. So this definition, you get it in your exam guideline, you get it in your CAPS document. Learners, you must take the definition as is. Don't put other words. Read it in an exam guideline. Memorize it as the way it is, because you are going to be marked as it is in an exam guideline. What is work? Work is a product. I spoke about work. It's a product. Product means multiplication. That is a product, right? Work is a product of force applied, right? This is a force applied on an object and the displacement is in the direction of the force, and the displacement is in the, so it's a product of force applied and what? Delta x cos theta. Right, I just want to bring this, the product, so that in your mind must link that if we talk about product, we talk about what? The multiplication. We are going to multiply what? The force that is being applied to an object and the displacement that the object has been displayed or displayed, right? So so there is, if you apply a force on an object, certain object, it's going to move to a certain displacement, or then it creates a distance between where it was and where it's going to be. So that it's a displacement or a distance that it has reached. So we are going to apply the force that, multiply the force, that means applied plus, with the what? The displacement. So that you need to know. So I'm trying to interpret the definition. Now, I always say to learners, if you want to know the definition, go to your data sheet, get this formula, and interpret what the formula is saying. The formula is saying work, which is this one, work is a product multiplication, a product of force applied on an object and the displacement. This is delta x, the displacement, in the direction of the force. All right, this, it gives you a definition of that. You don't have to cram it. You look at it, you are given this in your data sheet. You are given it. So just talk to it, turn this into words, then it will give you the 2 marks that you desire to get in the question. Right. So the definition itself, it gives us the formula that we are going to use to apply, to calculate. So what does it say? In our formula, we have W. What does it denote? It denotes work done in joules, because that's the SI unit of work in joules. And then F is the magnitude of the force in newtons. That is a force. We know force is always in newtons. And then delta X, which is the displacement in meters, which is the distance reached in meters. And the theta there is an angle in decrease between the force and the displacement. So the theta there, which is cos theta there, it's an angle, because we are going to use, the formulas working at an angle. So you need to have an angle. So this is the formula that you are going to get in your data sheet. We know previously we used to say work is equals to force times distance. Then we end it there. But we are going to use this with the angle, with the cos theta. So it means something. We'll get why the cos theta. We'll get it as we move along. All right. I know that you've got questions. Why the cos theta? But we'll clarify, because only it says the force. It's a product of the force applied and the displacement. It should be like that. But we'll explain why the cos theta. But this is the formula that we are going to use to calculate. So get in touch with it. Take notes, which is very important. Work, it's a scalar. It is a scalar quantity. It has only a magnitude. It's a scalar quantity. Remember, we've got the scalars and the vectors. Vectors, they have both magnitude and the direction. But here, vectors, work, it's a scalar quantity. Scalar quantity, it has only one magnitude. It does have magnitude only. So that is a scalar. And then a negative value of work indicates the loss. Remember, we're going to deal with positive work and negative work. So the negative, it means there's a loss of energy. Remember, that sign doesn't mean, the sign negative that we are going to see, does it mean that then it means a direction? No, it tells us about the loss of energy. And then the positive value, it tells about the gain of indicates the gain of energy or kinetic energy. So there is a loss, there is a gain. So this those signs doesn't mean anything to say this is a vector. Once you see a negative value, then we'll conclude that, oh, it is a vector. No, it is still a scalar. It only tells you about the loss and the gain. That is what we need to know. And then the SI unit, as I've alluded in our framework, that the SI unit of work, it is a joule. Jones Joule, it's a name of a person. So if we write it as joule, the J becomes smaller. But if we write it in a symbol, the J must be a capital letter. So we know many a times after calculation, we only write the symbol, which is J, representing joule. It should be in a capital letter. But if you write it in full, then you will write 2 joules. Then the joule, if you write it with a name, it should be start with a small letter J and then the name. Now, what does joule represent? Joule says 1 joule is equals to 1 Newton multiplied by 1 meter. 1 joule, it gives you 1 Newton multiplied by 1 meter. This equals to 1 kilogram meters squared per second squared. So this, it should be meters squared per second squared, right? So in other words, there are 2 meters there. Meter times meter, it gives you meter squared. So dot per second squared. That is how we get it. Because remember, this Newton is kilogram meters per second. And we multiply this one and that one, we get this one. That is how we got it. All right. So we don't want to bring confusion. I want just explain where do we get the meter squared. We get it from the meter of this Newton and the meter from this one. So we got kilogram meters squared per meter squared. Right. This is what you need to take note of. Take note of this. Don't lose it. And then it will bring the understanding as we are unpacking. All right. Now, positive work. What is positive work? Remember I said when it gains, you get energy, we have positive. All right. Now, when the force and the displacement are parallel to each other and move in the same direction, and the angle is 0, then you get what? Positive work. Once your angle gets 0. Now, if you look at the demonstration that we have, we've got an object here seated on the surface, and then the force is applied in this direction, and then the movement of the direction of the force is this way. Then from this point to that point, the force is being applied to move the object to that point, then it creates what? A displacement. And look at this. The force applied is in this direction, that is the force applied, and then is parallel to the displacement and in the direction of the displacement. In other words, both of them, they are going in the same direction. So in other words, this is a displacement moving in that direction, and then the force, they are moving in the same direction. If you've got the applied force and the displacement parallel to one another and moving in the same direction, we've got what? We've got a positive work. A positive work, and the angle there is what? Is less than 90 degrees. So the angle of this is less than 90 degrees. Hence, I said we need that cos theta because we're going to use the angle. And the angle is going to be less than 90 degrees. We'll see when we go for calculations that the angle, if the force and the displacement are moving in the same direction. Remember, they must move in the same direction. As they move in the same direction, then it means, therefore, the force and the displacement, the angle there is 0. All right? So, and the angle is less than 90 degrees. So, in other words, if we put cos 0, what is cos 0? Cos 0 is 1, isn't it so? If you can go to the calculator and press cos 0, it'll tell you that it's 1, right? Now, in other words, then you get what? The positive work. So, this is how we get the positive work. So, I want you to remember this. As we are going to calculations, we are going to apply this in our calculations. This is something that you need to remember. Remember, we will be giving in your read, you will be reading the problem statement. Then what we are looking at, we're looking at the force, the displacement moving in the same direction. All right? Immediately if they move in the same direction, the angle is what? Your angle of theta is 0. Sorry, the angle of cos is 0 there. So we're going to use that cos. So work is done by force is positive, the angle is less than 90 degrees. That is very important. Negative work, it's an opposite. When the force and the displacement are parallel, they're always working parallel. Not always, they work just parallel to each other but the point is opposite direction. But they point in each direction. In other words, you've got the force that is applied, pulling force, is applied there, is pulling the object that way, but the displacement is moving is that way. So these two are working in opposite one another. So you've got the force pulling that way, this one, the displacement is that way. So they work opposing one another. Remember, once they've got opposing, we think of what? What is this? A friction. Right? A friction. So, in this case, if they are opposing one another, the angle is going to be greater than 90 degrees, which is the angle of 180 degrees. So, in other words, our cos in this regard will be 180 degrees in this regard. So what is, I want you to go to your calculator and see why we say this is a negative work. If you say cos 180 in your calculator, you'll get -1. Just you click cos 180, then we said equals to, it gives you -1. So this is the loss, is minus work. So work done by the force in negative, the angle is greater than 90. Remember the one we dealt with, the angle is less than, if it's 0, it's less than 90. This one is greater than. If they are moving in the same direction, the angle is going to be 0, and the cos 0, it's 1. All right? If this one, they are acting in an opposite direction, what you get, the angle will be 180, and the angle will be greater than 0. All right? And then the negative will get the negative. And this negative does not mean this is a vector, does not mean a direction. It means the loss. I want us to get it clear. We are talking about the loss of energy. All right? Because work is energy. Energy is work. So we're going to deal with energy when we come to energy, but you need to get the clarity in terms of work and energy. So this is what it says. So I'm happy. If we are happy, you are getting what we are saying. You calculate, then you get minus this. So I want to emphasize as well, again in this one, if your force and the displacement are pointing in the opposite direction, the one that we started with, they are at the same direction or in the same direction. This one are in opposite direction. Your angle is going to be 180. All right? So you must get this into your head. You must know this and keep on practicing, because it's going to help you in terms of calculation. Once you understand this concept, it's easier for you to deal with any calculations that come across. All right? The zero work. What do you mean by zero work? when the force and the displacement are perpendicular to each other, the angle is 90 degrees. Remember, we started with the angle of 0 degrees. We came to an angle of 180 degrees. Now we come to an angle of 90 degrees. All right. Now, here, if your pulling force is perpendicular, it's going out perpendicular, we means 90 degrees, isn't it so? Perpendicular. It can be pulling down, but as long as it's perpendicular to the surface. Now, but your distance is moving in that direction. Just making an example. Now, it tells us that this is 90 degrees. It says it's 90 degrees. It's perpendicular. 90 degrees means perpendicular. So your cos there, your cos theta is going to be 90 degrees. What is 90 degrees? You can go to the calculator and say cos 90 is going to give you 0. So that's why we have 0 work there. The work done by force is 0 because cos theta is equals to 0. So this is what we need to come up with and we need to understand, because we are going to use this in terms of calculations and it's going to help you in terms of calculations. So when the force, take note, when the force and the displacement are perpendicular to each other, the angle is 90 degrees. When the force and the displacement move in the same direction, the angle is 0. All right? Because we are going to cos 0 is equals to, right? Then when the force and the displacement are opposing one another, moving in an opposite direction, we said what? We said the angle there is going to be 180. Now, when the force and the displacement are perpendicular to each other, what is the angle there? It's 90 degrees. And then 90 degrees, it gives you a 0. So this is what we need to drill ourselves. We need to practice. We need to get into our mind that as I'm going to calculate, these are the things that I must look at. I just want to go a bit once more. I want us to look at this. You take note of this too. The force and the displacement, and they move in the same direction, then the angle is 0. In other words, in cos, you're going to put 0. Right? You get the answer. That one thing that I want you to know. Then we look at it, this one, the second one. We look at the force and the displacement. They are moving in an opposite direction. Then what is an angle there? 180. All right? This is what I want you to get because it's going to help you. Then we have the 0. We look at this one, the force and the displacement. What are they doing? They are perpendicular to each other. They are at 90 degrees to each other. Then what is going to be your angle? It's going to be the 90 degrees. So this is what, learners, I need you to understand before you can go to calculations. Because we rush to calculations and we don't know what is happening to calculations. Then we got start and then we get 0. But once you get this from onset, then you've got this concept in your mind, then it's going to be easier for you to go for calculation, because you will know always we will be using the formula W equals to F, which is F applied, if it's F applied, times delta X cos theta. You'll be using this formula. So this is going to help you in terms of this. If you read your statement, if you read the statement, you will, this what I was saying from positive, negative, and 0 is going to help you in terms of filling in this cos theta. So it's very important that you understand this. It's very important that you align yourself as to what is it and what does it say to you. Now, force is applied at an angle. Force can be applied at an angle. It's not that it's only in a straight line or in a linear. So this is applied at an angle. When a force is applied at an angle with a horizontal, all right, this is the force applied at an angle. This is the angle theta. That is when this is the force applied, all right, to the horizontal. That this is our horizontal. The angle between the displacement is equal to the given angle. So you may not calculate. Many a times, what do they want you to calculate? They will want you to calculate the force, the applied force. And it's not easy just to calculate the force while it's at an angle. So you must use what? The components of vectors or the components of forces to calculate, to make this angle to be at the parallel to the displacement. Because this angle will be, this force will be parallel to your displacement. So the component of vectors will make this force to be parallel to your displacement. So what does it say? Work done by the force is positive. The angle is going to be less than 90. That is what we said it. Because if this force is now parallel to the displacement, it's going to move in the same direction as the displacement. So it gives what? The positive work. Is what we said it. So you will see when you calculate, you must make this force at an angle. This is acting at an angle to be parallel to your displacement. And they will be moving in the same direction. Then your angle there is going to be cos 0. Remember, that is going to be cos 0 because this cos is parallel, this is parallel to that one, and then this angle should be less than 90 degrees. So it's less than 90 degrees, all right? So if you say cos 0 is going to give you 1, that is cos 0. So it's what we said. I'm just repeating what we said, but now I'm showing you that this is applicable, and this is how you need to apply it. Work done by the force is equal to the work done by the horizontal component. In other words, you must make this force to be horizontal. Then we will use what? Components to calculate, to make this force to be parallel. The component of vectors. We have dealt with in grade 11, the component of vectors, how to calculate the component of vectors. And to calculate this component is going to be fx equals to force cos theta. That is the formula for component. If we are talking about the horizontal is fx because we are talking about the x-axis. Then if the vertical is the same, is going to be fy. Fy equals to f sine theta. If it's sine, it depending on where if we complete the triangle here, then we've got this triangle here and this force. Then this side is going to be sine, this side is going to be cos. So if we say we calculate for y, then it's going to be fy equals to f sine theta because of this is facing the angle. So this we call it component of vectors. All right. So, but because we are talking about the parallel one, and then it's horizontal, we'll be considering this one in most cases. I think you understand. I think you follow what we are talking about and what we are doing. So I'm just making this case so that you may see what is it that we are talking about in terms of the trigonometry. In technical maths, we are doing the trig ratios. So these are the trig ratios that we are dealing with even in technical sciences. Now, tips, because we are going to calculations now. Tips on answering questions based on work. This is very important. I'm not saying all are not important, but the first one, take cognizance of. It's very, very much important. Read the given statement. Read. Reading is very important. We read for understanding. We don't assume that the examiner says. No matter how easy the question, read for understanding. Because once you read the first line there, then you think as if it's saying that, then you'll get it wrong. Read throughout and then understand read with understanding what the examiner is saying to you, or what is the extract is all about. And then list the data. Get the data. As we are reading, underline, circle, collect the data, because it's going to help you. The data is going to help you to identify a correct formula in your data sheet. So it is very important that you read with underlining, you circle, you collect the data, so that this is become easier for you to understand if you do that. Determine the direction of the displacement. This is what we're talking about. Look at your displacement. Is acting opposite to your force, or they are moving in the same direction. So determine your direction of your displacement. If you push the object in the same direction as a displacement, you know what is happening. If you push the object in an opposite to your displacement, what is expected of you? This is very important. Determine your direction of your displacement. Now, this one and that one will learn when we are talking about forces, when we're dealing with forces. We have dealt with forces with your teachers when we start at the beginning of the year. Newton's second law, they want you to draw the free body diagram or the force diagram of an object. Learners, I may not emphasize this over and over again, but I want to say this. These are the free marks that you need to obtain. It depends as to what type of forces are there. This is an object lying on this surface. Then this is the force applied. This is the force applied. Then they say to you, draw the forces that are acting on this object using a free body diagram. Now, I want to emphasize this. Look at the marks. How many marks are there? If it's 4 marks, it immediately tells you that you need to draw four forces that are there, because already the marks indicates the number of forces that are there. If it's 4, let it be 4. Don't exceed 4. Now, the free body of this is going to be the dot. We know that we always denote the object with a dot. It's going to be this force, which is the applied force. It's going to be a gravitational force, Fg. Is going to be the frictional force, which is the force that acting this way, a frictional force. Then it's going to be the normal force. These are the 4 forces that are acting in this object. Then it's 4 marks. So, indicating all the forces acting on an object, I've indicated them, all the forces. But what is going to direct you is the marks awarded. If it's 5, there should be 5 forces. It means there will be this force. All right. Determine the angle measured from the direction of the displacement on each force. The angle, remember we spoke about the angle. The angle that side, it will tell you that if they are moving in the same direction, 0. Even they are moving in a opposite direction, 180. If they are perpendicular to each other, then it gives you what? 90 degrees. So those are the angles that you need to know. So I may not emphasize this over and over again, but I need you to understand that as we have unpacked all the positive, negative, and zero work, so this still emphasizes that which type of an angle is measured there. So it's very important that you know the types of angle. Copy the formula given in a data sheet. Never, learners, formulate your own formula. I know you're a scientist, you like to formulate everything that you come across it. Don't invent the wheel. There's no time in an examination to invent. Get your data sheet, know your data sheet, collect information. You see the collecting of data that we said it in the first line there. It will help you to get the correct formula in a data sheet. All right. Make a direct substitution from the given data. Learners, if you calculate work equals to F delta X cos theta. They say to calculate force. Learners, never make a subject of the formula. You'll confuse them. Substitute direct in the formula that you picked up from the data sheet. So what do you do? If this is 20, your work is 20, then the force is what they said, calculate the distance, it's 2 meters. All right. Now what you do, 20 joules should be here. The unknown is what you want to calculate. Multiply by 2 meters. Cos 180, because they are moving in a opposite direction. All right. The force is moving in a the direction to the displacement. So what I'm saying, I'm just assuming. All right. I'm substituting directly to what I got from the data sheet. Never try to force equals to, then you start becoming confused. Then you say W multiply by cos theta over delta X. You'll get wrong. Already you are wrong. Already you are wrong. So don't do a subject of the formula. I appeal with you. Don't make a subject of a formula. Substitute directly to the formula that we have get. So this is very important. Right. Write the final answer with the correct unit. I may not emphasize this once more. The correct unit, if you calculate for work, then the correct unit is joule. That is what you need to do. Correct unit. You cannot say calculating for work, then you come with Newton. You'll be penalized, right? So these tips, learners, are very important. I want you to take it serious. I want you to go over and read. You know, reading is very important. Read for understanding. If you don't understand, ask. There are things that you ask, you read. You ask, you read. And you seek information. Don't just be in a cocoon and say, I'm fine. Right? These are the tips for answering basic questions in work. They don't work only in or confined in work only. They may apply in other topics. But this I'm giving you as a tip. Right? Conversion. Let us move now. Conversion, learners, this was done in grade 10. That is the first topic that you did in grade 10, conversion. And you move along with it, grade 10, grade 11, right? Once you start getting it right in grade 10, you'll never go, because the examiner, remember here we're testing the skill, right? The skill of converting. Remember, we are using what we need to use when we calculate. Then we're giving something that we not use when we calculate. You convert it to what we use in calculation. For an example, we will be given grams. We cannot calculate with grams. We only calculate with what? Kilograms. So you need to calculate to convert grams into what? Kilogram. So 1 kilogram is equals to 1 gram. So by way of conversion, in other words, if we have 1,000 gram, we'll divide by, we want it to be in kilograms. So it means we need to divide 1,000 gram with what? 1,000. Then it will give you what? 1 kilogram. Right? So we divide by 1,000 if we want kilos. If we want to take centimeters into a meter, we divide by 100. So this is very important. We divide all the time. Look at what we are given. Then we will divide this by 100. We dealt with this one when we calculate, we convert kilometers per hour into meters per second. So the velocity or the speed, kilometers per hour, you divide by this 3,6, which is 3,600, right? To get what the meters per second. And then kilowatts, kilo, it's 1,000. So kilowatts, if we have watts, we want to take it into kilowatts, we will multiply by, if we want to take kilowatts into watts, it's when you multiply the 1,000, this is 1,000, by the number that you have by 1, it gives you what? The watts. Because we don't use kilowatts, we always use watts. All right? So all the time, remember, if we've got kilowatts, we must bring it to watts. Then we multiply. If we've got grams, we bring it to kilograms. We need to divide. So don't be confused. When we're dealing with power, because we're going to use power, this is what we use. We're going to deal with horsepower. 1 horsepower is equals to 746 watts. All right? In other words, as we are going to deal with, we are going to multiply any horsepower with what? The 746 to become what? A watt. So these conversions are very important. So we'll deal with this one when we go to power, or when we come to power, then we'll deal with this one. But I want you to remember, these conversions is what you're going to encounter when you go for calculation, or you make calculation, or you do calculations. So these are very important. So learners, this is what you are going to use. This table of conversion is going to help you to remember all the time how or when must I convert and how should I convert. So that is very important. So stick it in your book, revise it, practice it all the time. Practice, say, make perfect. So you'll practice, you'll get the answers. And then never use grams, never use centimeters. We use kilograms, we use meters when we calculate. Right. Let us get to the business of the day, calculations. We want to apply all the knowledge that we have started with in calculations. Because at the end of the day, you'll be asked to calculate. The only thing that the examiner will ask you from what we started with is the definition of work. That is 2 marks. It's always be there. It's going to be there. Definition of work. If you can go through the question paper, you can see that 2 marks is always there. Defined work, done. Defined work, done. 2 marks. Defined work, done. 2 marks. So it's going to be always there. But the nitty-gritty is the application thereof, of what we have alluded or what we have said at the beginning up to now in terms of calculations, because you need to do calculations. Now, let's take this work example. At first, then I said we go to the tips now, the tips that we have read in terms of calculations. The force of 90 Newton, the force of 90 Newton is exerted at an angle, we're given the angle of 60 degree on an object, right, of 2 kilogram. Lucky us, we're giving our mass as kilogram. We don't have to convert here because they are in kilogram. And causes an object to move in a direction, to move a distance, we're given a distance of 120 centimeters, here's a snake here, to the right from point P to point Q on the horizontal rough surface. This is what we are given there. Now, this is our snake, and this is acting at an angle to the horizontal. Now, I want you to go back to what we have said as I'm reading, and think what is going to happen, right? Now, first thing first, collect your data. We've got a force that is exerted or applied, which is 90 Newton. We've got the angle of 60 degrees. We are told that the distance at delta x is equals to 120 centimeter. Now, the next is that we've got this we need to take care of. We don't calculate using centimeters. We use meters when we calculate, right? Take into account that. Now, a magnitude of the frictional force. Now we're given another force, which is the frictional force. Between the surface and the object is 20. We are given a frictional, we add it there as a frictional force of 20 Newton. This is the data that I'm collecting. As I read, I'm collecting the data. It's going to help me as I move forward with my calculations. All right. Now, I've got the data. I've read the statement with understanding. What do they mean? Or what does it say to me? Or what do they want me to do? One, they want me to define the term work. I've said it to you. Define the term work. We go back in our definition of the term work. What work? They want you to define the term. What work is in terms of science. Remember what comes to your mind? It comes the product, the force, the displacement, right? In the same direction. So that comes into your mind. So in terms of defining your work. Then they want to, without convert the conversion. It's part of the mark. You can do it there, but it's part of the mark. This, they are testing the skill of conversion. That's the skill. Remember, we from the chart of conversion or the table of conversion. So it must come to your mind. If we say, if you convert 120, what does it, centimeters? So centi means 100, right? Centi means 100. So I know as I'm talking, you are writing, you are trying to solve as much as you want, right? Two, they want to draw a free body diagram. And all the forces that are acting. What will show you the forces? How many forces? Is your mark there. So you see, as I'm doing it, I'm just juggling around. I'm just doing it around so that you may understand. Right, we move faster. Then you come to calculate the work done. Remember, this is one section, this is another section, right? In 1.1, they want you to calculate this. In 1.4, they want to calculate, you're still calculating. Then you will be calculating the applied force, the frictional force, and the gravitational force. And what is work done by the normal force? This, I love it. Give reasons for your answer. All right. This is what they want you to do. Now, before I can give you an answer, I want you to think, because I'm going to explain the answers. The answers are here, but I want you to think. Let us think about this one first. I gave you the 2 marks for this one. You think about it says work done is the product of force applied in an object to a displacement in a direction of a force. That is work done. That is a definition of work done in words, right? In other words, I said you go to your Data sheet, you say work equals to force, right? Product delta x cos theta. Then you set it in two ways. So I've given you the definition. Work done is a product of force applied in an object in a distance, to cause a displacement in a direction of the force. That is your 2 mark. That 2 marks, 2 or nothing. 2 or nothing. Right, the conversion. The conversion, before I go to your answer, we say delta x, which is the distance, equals to 120 divided by, what is centi? 100. Then your answer will be 1,2 meters. All right, you can go to the calculator and do it very fast. Then we go for the free body diagram. I said the free body diagram, we want the free body diagram of this object, and then it's 4 marks. Remember, we said we denote the object with a dot. It's a free body diagram, not a force diagram. We've got the force that is acting at an angle. This is the force acting at an angle, which is the force 90 degrees. Sorry, 90 Newton. All right? We've got the force that pulls the object downwards, which is the gravitational force. We've got the force that is acting opposite the object, which is this force, which is a frictional force. How many forces that we have now? We've got 3 forces. And then the marks, how many? They say 4. So it means we're short of 1, right? So you cannot leave it at that. You'll be penalized. So you'll get 3 out of 4. But we want you to get 4. Then remember, we've got the force that's acting perpendicular, which is the normal force. Normal force. So these are the 4 forces. This is 4 mass. These are the 4 forces that are acting on an object. All right? So I've answered this question. Let us see that this is correct. This is your answer. The product of applied force in an object displacement in a direction of a force. This is what we have answered. Now we have answered that if we convert centimeters into meters, we divided the 120 with 100, it gives us 1,2. Voila, we are correct. Then we go. This is the force diagram that we spoke about. So the force diagram, we've got this force, and then we've got that force. This is a frictional force. This is the normal force. Then we've got the 4 marks. So this was taken from the exam question, Lenas. So you see, we have 2 marks there. You've got 1 mark there. You've got 4 marks there. Already 7 marks in the back. So simple 7 marks in the back, right? Now, we are asked now to calculate applied force, frictional force, and all these forces, right? Then let us move. Let us see. Now, I'm going to talk to the solution because we left with few minutes. All right. Now, remember, you go. This is the formula that you need to have. Now, they said the applied force. All right. We need to calculate the applied force. Now, remember, our diagram is this way. And this is 90 degrees. This we're given as 60 degrees. Right? Now, the distance that we are given from there to there, it moves there. They said it's 120 centimeters. And we have converted 20 meters, 120 meters into meters. It gives us 1,2 meters. So we're going to use this one, not that one, because this is in centimeters, right? Now, we go to the data sheet. We find the formula that is there. that formula is going to be there. All right. Remember, when we go back, we are thinking that this is gonna be giving us the horizontal. All right. The horizontal force, and is moving in a direction, same direction with what? With the displacement, right? Now, in other words, if we calculate, this force is going to be parallel and moving in a direction of this one, right? Now, look at the angle there. The angle is less than 90 degrees. Remember, they said the angle should be less than 90 degrees. Then that's why we are having the cos there. Then we have this force, which is, we substitute there. Remember, I said you substitute direct to the formula. Now, we are having 90, which is this one. We are having a distance multiplied by the distance, which is the product. The distance is 1,2. We have converted it. Then the angle we are given there, which is 60. Then if you multiply all of this, it gives you 54 joules. All right, 54 joules, which is the work done in this. It's 54 joules. All right, so that's why we have used the angle there, because it's parallel. Well, we want this force to be parallel, right? Right. Now they say calculate the work done due to friction. They are specific here. They said due to friction. If we go a bit move quickly, the friction there, they are specific, and we are given a friction when we collected our data as 20. There's the friction there as 20 Newton. So read the statement with understanding. Is 20. All right. So we substitute. We dealing with friction, right? Remember, once it's said friction, the object it's there. It's moving this way. All right. This one is moving that way, which is your distance to 1,2. Then the friction is moving that way. Do you see that there's an opposite? Remember, when we said an opposite, what comes to your mind? The angle should be bigger than 90 degrees, which is 180. That's why we have this 180. Don't be fooled where if we get the angle. Remember, the friction there is moving opposite to the displacement. Then once they are opposite one another, the angle is 180. So that's why I said you must recall whatever that we have said at the beginning. So that's why don't get confused where this 80 come from. I mean 180 come from. It come from the opposite direction, right? No, the 20 is a friction. Remember, the friction we are given as 20 Newton. So we have 20 Newton. This is the distance is moving in an opposite direction. Then the angle, because they are moving in an opposite direction, it's 80. Then you can calculate. Remember, cos 180 is minus 1. That's why we are getting this minus. Because if you multiply by minus, you'll get by a minus 24. And this minus 24 doesn't say it's a direction. I must repeat, we don't have a direction. It tells about the work. It's a negative work. All right? It's a negative work because it's in joules. Negative work. So it's a loss of energy. And so the energy is lost. Now, the third question says calculate the gravity, the work due to gravity. Remember, gravity, we talk about W, which is not work, it's weight. Weight is mass times gravity. All right? So I want you to not to forget this because they talk about gravity. Now, let us they become confused as to why this now. Where does this come from? This comes from here, and this force gravity denotes this. The M is for a mass, which is the mass of an object is 2 kg, we're told, right? It's 2. Then the G we know it's equals to 9,8 meters per second squared. It's there, always there, right? So you'll get it in your data sheet in a constant. So you take that 9,8, you don't have to claim it, it's there, you'll be given. That 9,8, you put it there. Then it's 2 times 9,8 times the distance. This is the distance. Now, cos 90. Where does cos 90 come from? Remember, we said the gravity is working perpendicular, right? FG is working perpendicular to the surface. Now, perpendicular means what? 90 degrees. Do you still remember that? So that's why we take this angle as a 90, because it works perpendicular. Oh, wow, it's nice, eh? So this, it's 90, so we put it there as 90. So I don't want to be confused where this come from. We have said it when now we are unpacking what we said in terms of positive work, negative work, and zero work, right? So cos 90, if you press it, you say cos 90, it will give you 0. Already this is 0. And if you multiply everything by 0, it's going to give you 0, right? It gives you 0. So we have calculated this. Then you've got 0 work. Oh, I love this because it explains whatever that we have said at the beginning. Now, the question, the other side says, let me just move faster to the question. What work done by normal force? We know if we've got normal force, we are going to have a 0 work. Sorry, is what we said there. Already, the joule there, it's 0. It's 0 work. Already from here, it's 0 work because it's perpendicular. Normal force, it's perpendicular. So it's either you are going to write 0 work or the normal force is perpendicular to the displacement. Once the normal force is perpendicular to the displacement, then the angle, the cos is cos 90, which is equals to 0. So that is how you get marks. And this was 3 marks, 3 marks, 3 marks, and 1 mark. Look at the 10 mark, free 10 marks. So this is how we are going to attack the statement problem if you are given that other side, right? So I want you to apply. I'm applying the knowledge that we have started with. Then I'm coming with it step by step so that we understand where this cos come from, where this angle come from, so that you may not get confused. Once you understand the concept, understanding of the concept is very much important. So it's the understanding of the concept that will give you where does this come from, where the angle come from. That is going to be easier for you, as I've just explained. Right? Let us go to one activity or 2 activities, and our time it's running short. Now, multiple choice questions. This is a serious questions that it's out of 20 marks. And learners are failing the multiple choice questions because they just pick and choose. They don't read. Remember, we said read for understanding. All right. Multiple choice questions. There are 4 possible answers. These are possible answers. They are not answers. There is a real answers part. We've got possible answers is what we call them. And there are 3 distractors and 1 correct answer. Right? We call them distractors. So my advice to you is to say, eliminate the distractors first and then get the correct answer. Now, that's the statement. You'll get what I'm saying. Which one of the following statement is true? Which one of the following statement is true? Right? Work is done when. Remember what work. Remember the definition of work. Remember what work is. What is in work? We are expecting the applied force. We are expecting the displacement, right? In a direction of the force is what we expect, right? When we talk about work, right? Now they are saying work is done when the force is at 90 with the direction of a force, of a displacement. Oh, well, I've heard about this, but I'm not sure about that. Reserve it. The displacement is in the direction of the force. Oh, I think this one, I heard about it as well. And I think it's getting there. there is no resultant force and displacement is 0. This I never heard of it. Eliminate it. All right? The displacement is 0 and the applied force is greater than 0. I never heard about this as well. Right? So I've eliminated C and D. They are out. All right? Now I've left with 2. I've left with A and B. Then I must choose in A and B, which is the correct one. Then I go back. What is force? What is work done? Work done is when a force is applied on an object and it causes the object to move. It causes the object to move in a displacement, right? Now, and then the displacement, and they are in the same direction as a force. We want that in the same direction of a force. Now, we have the displacement in the same direction of a force, all right? And this one, the force is at 90 direction. This is going to be perpendicular. It's when the force is perpendicular to a displacement, which is not correct, all right? It's something else, this one. So, this is not correct. But the answer is this one, because it should, by the definition, the displacement is in the direction of the force. So that is how you start with the one that are wrong, you eliminate them, you left with 2, then you read the statement, it'll give you the correct answer. That is how you go for a multiple choice question. Right, let us go for this one. This one, I'm going to do it quick, but I want you to look at it in a context of knowing the multiple choice. I'm dealing with a multiple choice question because learners, they don't get multiple choice. I understand multiple choice questions, you must get all of the answers. 20. Read. Don't be lazy to read. Read and then you eliminate. A crane is moving a pallet of bricks to the right while it applied an upward force of this. This is an upward force over the height of, this is the height you are giving. And the mass of the pilot, we are given the mass of the pilot as it showed, all right, in the sketch. Now, the amount of work done to the pilot by the applied force, we want the work done, right? What is it? Look at the answers and eliminate what is not there. Just let's think about quick. 1, 2, 3, 4, 5. What do you eliminate there? 1. Already, if you look at number 1, I'm not sure because I need to do calculations. Let me reserve number 1, right? But if you look at number 2, which is B, number 2 is the same as the mass that is there. It cannot be because something has to be worked out. A mass cannot be in joule immediately. So we're given as gram. This is not. Number C, I'm not sure of number C. I must come and think of it. It means this one and that one. Look at number D. Number D is the same force that we are given there. And it has been turned to joules. The force cannot be turned into joules going upward. So I've eliminated B and D immediately. I've taken out. So I've left with 2. Now I must get the correct answer to 2. Now, this one, I'll work it out. But what I know, if a force is working, it's exerting perpendicular. This, what I think of. This is perpendicular, which is 90 degrees. Isn't it so? And of course 90 is equals to 0 degrees. 0. So what is your joule? What is your answer there? The answer is C. Then this one is incorrect. That's what we have. So that is how you go for a multiple choice questions. That is how you eliminate your answers in a multiple choice questions. So this is the question that taken from DBE. The question that was, the paper that was written in 2019. I've extracted this question. Now, what do you look at? We are given that a man applies a force of 200 Newton to pull a crate of bricks over a distance of 9 meters. The total mass of the crane with the content is 120. As I read, do you see that I'm collecting the data? I'm underlining. I'm making sense of what I'm trying to underline. Fortunately, we are given in a sketch, right? Now, this is the force applied. This is the distance reached. And then they are on top. There is a friction that's acting against this force, the friction of 40 Newton. It's not mentioned in the statement, but it's there, right? So you look at all the details. One is not in there, look at the sketch, it tells you, or the drawing, it tells you, it gives you information, right? They want you to define, I said it, and I'm still going to repeat it, the definition, define the term work done. We're looking at a force applied. We look at the product of delta x cos theta. This is your definition of work. Said it in weights, right? They want you to say it in weights, but you start there. The product, start with the product, the name product of the force applied to object in a displacement, and then it causes the object to move in a direction of the displacement, right? Or of the displacement moving in a direction of the force. Remember the answer that we said. So the directional force must be there. So this is gonna help you not to memorize but to know, right? Now we are asked to calculate the work done by friction. Right? Work done by friction. Work done by friction. If we ask to work done by friction is equals to F delta x cos theta. All right? Now, the work done by friction, your friction you are given as 40. Then your distance, it's 9 multiplied by cos. Remember, the friction is moving opposite direction, right? To your displacement. The friction is going that way, the displacement this way. Then what comes into your mind? Cos 180 if they are opposite. All right. Then you can go to your calculator, you find the answer there. All right. We'll go into the answer, but the interpretation is what they want, which is 3 marks. What should be the size of the angle between the applied force and the direction of motion for the work done for the crate and its content to become zero? Become zero. What should be the size? The size will be, because remember, if the work done is 0 joules, it tells you it's acting perpendicular, right? It's acting perpendicular, and the size will be 90. The angle of the size will be 90 because it's acting perpendicular. You're already being guided by the 0 there, 0 joules. So 0 joules is equals to 90 because it's perpendicular, right? Then you've got calculate the net force, the net work of the crate. Now, the net work, it means you are going to include, net means all the work, the forces that are acting there, right? You are going to combine them. It's going to be net work equals to, you've got applied force, all right? Then plus your friction times delta x cos theta. This is your formula, all right? Then you'll apply, then this is 200 plus 40, then this is your 9, then this is cos. All right. Then we'll calculate. Then let us check our answers. All right. Sorry. I said, sorry, let me just, this because it's going to be minus, because it's going to be, this is going to be cos 0, sorry. I want to say cos 0, not 180, because it's going to be moving in an opposite direction, right? Now, as I've alluded, this is our solution. I've defined this one. I've explained if we immediately we've got the friction is going opposite to your displacement, we use 180. Then you got the answer as minus because of this minus. This is not the direction, but is the energy that has been used. Then there's the 90 there. I put it there because of 0 joule, right? Then, or he said it's perpendicular to each other because they are perpendicular, is what I said. Then this is the force formula for the net force, all right, or net work. That's different. Hence, I said, look at this. We have taken all the forces that are there. We minus, then we get what? We get, this is the answer that we get. So you can work it out as long as you familiarize yourself as to what is the statement says to you. All right. This one, quickly. It's a homework that you should do at home. Let me just explain it, then we are going to close. A man is pulling a toolbox, this you are given. All right? Is the mass of this, of the toolbox. Then the tension that is given is 300, which is this one. Then at an angle of 40 degrees, the toolbox is moving or pulled at a distance, over a distance of 3 meters. Then we are given on the your picture there. Now, you may think of all the questions that you may think here. Number one, if they can say to you, calculate the force that is pulling the object, what comes to your mind? It's going to come with that, I must make this force parallel to this one. So once it's parallel, the force that I want is parallel to and moving in the same direction, then I'm going to use what? The angle that is less than 90, which is the angle that is less than 90. You see? So now, first, they want you to define. So that definition is always there. So it's very important that you know the definition because it's 2 marks, 2 or nothing. Then calculate the net is what I did. The net work done. Net work done is the forces, all the forces that are acting. Now, we are given the friction as well here. In other words, you've got this one and that one acting together or in an opposite to each other. Then you know which formula that we are going to do. And this extract was taken from DBE, the paper that was written, the first paper on technical science in 2018. So this is the abstract that was taken from there. You can do this. The only thing that you need to do, one, collect the data, read with understanding, know what is positive work, what is negative work, what is zero work. This is going to help you in terms of what? Knowing what is it, which angle you should apply. Then you'll never get this a question wrong. This is 6 marks. Total of this one is 6 marks. Every 6 marks, especially this one. Then you go to the calculations. You'll never get wrong with the calculations if you understand what we have said in terms of positive, negative, and zero. Then you'll get it. So, learners, this is how far we have gone today. This is how far our lesson has been to. Do this homework. I appreciate that you can do it and give it to the teacher and discuss with the teacher. Where you still have a problem, you can ask more questions. We are available to you for the questions. So I hope you have enjoyed the lesson. You have gained more to the lesson. You go to a framework, then the other lesson will be on energy, because we'll be doing energy. So we'll come next, we'll do energy, but we'll go through work as we have done today. I wish you a good luck in your practice. Practice make perfect. Always practice, practice, practice until you get it right. These are the free marks. These are the marks that you are going to get, especially when you come to the definitions. Thank you so much. I hope you can. Don't forget to sanitize all the time. Keep a safe distance, social distance. I wish you good luck. Thank you so much.